get ready for a discovery that is turning our understanding of the universe upside down. These findings are so unexpected that many renowned scientists now believe something big is on the horizon, something our current understanding of the universe is simply not prepared for. André Couteau, a postdoctoral researcher at the Lawrence Berkeley National Laboratory in California, said in an interview that we're in the business of letting the universe tell us how it works, and maybe it's telling us it's more complicated than we thought. With each new discovery, Webb is revealing that the cosmos may be far more complex and mysterious than we ever imagined. Recently, scientists analyzed 30,000 early galaxies detected by Webb and found something extremely strange that doesn't fit into our current understanding of cosmic evolution. But that's not all. Webb also studied 20,000 more early galaxies, and the results were just as baffling. This massive study suggests that what scientists once believed to be the expansion of the universe might actually be something completely different or even an illusion. Because of these shocking discoveries, many scientists are now seriously questioning, could we be standing on the edge of a scientific breakthrough that changes everything we know about the universe? Could it be that the Big Bang is not the real answer to the origin of everything? Only, we live in one universe right now and these numbers are not matching. They should match. It could be that there's something missing in our model, our standard model that has the dark energy and dark matter we've been talking about, and that there's another physical something that we have not yet discovered, and this might point to that. So what exactly did the Webb telescope find in the early universe, and why do scientists believe this is the end of the Big Bang theory? Recently, scientists published a new paper in Nature Astronomy in which they reported that deep observations from the James Webb Space Telescope have revealed an exceptionally large galaxy in the early universe. It's a cosmic giant whose light has traveled over 12 billion years to reach us. Scientists have named it the Big Wheel. This giant disk galaxy existed within the first 2 billion years after the Big Bang, meaning it formed when the universe was just 15% of its current age. It challenges what we know about how galaxies form. The detailed Webb telescope observations show that the Big Wheel is comparable in size and rotational speed to the largest superspiral galaxies in today's universe. It is 3 times as big in size as comparable galaxies at that epoch, and it is one of the most massive galaxies observed in the early cosmos. According to our current standard cosmological model, galaxies in this era of cosmic history should appear less structured, smaller, and lacking a well-defined shape. However, this particular galaxy has defied expectations, emerging as a remarkable anomaly in the early universe. Well, this is not the only massive and well-developed galaxy that the Webb Space Telescope has identified from this early period. Multiple such galaxies have already been discovered, but what makes this galaxy even more amazing than other galaxies is that this galaxy stands out as the largest among all the early galaxies observed so far. But wait, some more recent Webb telescope discoveries have found even more bizarre phenomena in the early universe. New discoveries from the Webb telescope have revealed a terrifying new fact about dark energy. Scientists have found that the mysterious force called dark energy, which drives the expansion of the universe, might be changing in a way that challenges our current understanding of time and space. Some of them believe that they may be on the verge of one of the biggest discoveries in astronomy for a generation, one that could force a fundamental rethink. This early-stage finding is at odds with the current theory, which was developed in part by Albert Einstein. More data is needed to confirm these results, but even some of the most cautious and respected researchers involved in the study, such as Professor Ofa Laha from University College London, are being swept up by the mounting evidence. The discovery of dark energy in 1998 was in itself shocking. Up until then, the view had been that after the Big Bang, which created the universe, its expansion would slow down under the force of gravity. But observations by US and Australian scientists found that it was actually speeding up. They had no idea what the force driving this was, so they gave it a name signifying their lack of understanding: dark energy. Although we don't know what dark energy is, astronomers can measure it and whether it is changing by observing the acceleration of galaxies away from each other at different points in the history of the universe. Last year, when dark energy spectroscopy instrument researchers found hints that the force exerted by dark energy had changed over time, many scientists thought that it was a blip in the data, which would go away. But after more than a year of observations, scientists have now confirmed that dark energy is actually behaving much more strangely than we thought. Professor Seshadri Nadithar at the University of Portsmouth said, "We've also performed many additional tests compared to the first year, and they're making us confident that the results aren't driven by some unknown effect in the data that we haven't accounted for." Well, recent observations from the James Webb Telescope also revealed that dark energy in the early universe behaved differently than it does in the current universe. Nobel laureate and lead author Adam Rees said that Webb's observations show something strange. The rate of expansion of the universe-driven dark energy seems to change depending on how it's measured. For example, when scientists study the cosmic microwave background, they get one value for the universe's expansion rate. But when they use predictions from our standard cosmological model, they get a completely different value. This mismatch is known as Hubble tension, the discrepancy between the observed expansion rate of the universe and the predictions of the standard model suggests that our understanding of the universe may be incomplete. Scientists previously believed that the universe's expansion was driven by dark energy at a constant rate everywhere. This assumption allowed them to calculate the universe's exact age and understand how it evolved over time. However, recent discoveries suggest that dark energy may not behave as expected. Instead of remaining constant, it appears to act in ways that challenge previous assumptions. If this research holds, it would challenge the assumption that all parts of the universe share the same cosmic timeline because it could alter the local rate of cosmic evolution. Some regions might have undergone accelerated expansion earlier or later than others, affecting how we calculate their apparent age. However, to explain all these mysteries, scientists have recently proposed a new model of the universe named timescape cosmology. In this model, scientists highlight the significant influence of massive cosmic voids and structures on the nature of time. In this new cosmological model, scientists have revealed that the expansion of our universe is not driven by dark energy, but is an illusion created by time. They propose that time flows slower in regions of space where the concentration of matter is higher. For instance, an atomic clock situated within a galaxy might tick up to a third slower compared to an identical clock position in the middle of a vast empty void. Now, think about this. Over the vast time scale of the universe is about 13.8 billion years old. But in regions with little matter like cosmic voids, time has been passing faster. So billions of additional years may have passed in these voids compared to the matter-rich regions. This means that the universe doesn't have a single unified age as we often imagine. Instead, the age of the universe could vary depending on where you are. The age of the universe may be greater in the cosmic void than in a denser region of space. Here's where it gets even more fascinating. Since so much more time has passed in the voids, these regions have experienced more cosmological expansion. In simple terms, the universe has been stretching more in these less dense areas. If you're looking at an object on the far side of a void, it would appear to be moving away from you much faster than an object on the near side of the void. This is because the space within the void has expanded more over time. Now, imagine this effect across the entire universe. As a result, when we observe the universe, it creates the illusion that the overall expansion is accelerating. But in this model, there's no need to introduce dark energy. Instead, the faster expansion in the voids naturally accounts for what we see. In 2017, astronomers from the University of Canterbury in New Zealand tested timescape cosmology against observations and found that it was a slightly better fit than lambda CDM to explain cosmic expansion. Moreover, in another recent observation of 30,000 galaxies by Webb Telescope, scientists found that most of them are rotating in the same direction. This is incredibly strange because, according to the Big Bang theory, the universe should have formed in a chaotic manner with galaxies spinning in random directions. However, this unexpected uniformity suggests that the universe may have started with an initial spin, something that current theories do not account for. Even more intriguing, some scientists are now considering the possibility that the universe itself was born inside a rotating black hole. This idea is not entirely new. In fact, it is part of a well-known theory called the black hole universe hypothesis, which proposes that our entire universe could actually be a giant black hole. All these discoveries are amazing and are revealing more mysteries about the universe and its nature. Well, that's the end of this video. If you found it interesting and informative, let us know your thoughts in the comments. We'd love to hear from you. Also, if you'd like to support our work, You can do so by purchasing our t-shirts or donating via Super Thanks. Your support helps us create more amazing content. Thank you for watching.